How's it going, Calc people? Today we are looking at 2-3 continuity. We did this last year, but we're doing it again because it's important, because when we do differential equations, when we take derivatives, when we get to real life calc land, you cannot take derivatives of non-continuous functions. So if it's not continuous, you just say, I can't do this, and you say, I'm dumb. Okay? So I'm trying to make your life a little bit easier. Continuity of point. Any function is continuous if you can draw without lifting your pencil from the paper. Okay? So this line is continuous. This drawing is not, because I had to take my pencil off the paper. Okay? Continuous. Not continuous. Okay? I just want to scribble my screen. Let's be honest about this. Example, continuity of point. Find the points in which the given function is continuous and the points in which it is discontinuous. Okay. Well, it is continuous. Well, I can draw from here to here, right? So it's continuous from 1 to, from 0, and we'll include it, 0 to 2. Because that's an open dot. Not actually there. There's a gap, gotta take my pencil off. It starts again at 3, and it goes to about 6. Okay? Okay. And so everywhere else is not continuous when it's less than 0, because there's nothing there. And it's not continuous when it's greater than 6, because there's nothing there. If you can't take the limit at that point, it's not continuous. Okay? That wasn't freezing, I was just staring you down. Okay. Right here, this is the big stuff. This is important, it's noteworthy. Any point on the function, or if a function is continuous, any point I pick on there has a limit. From both directions approach the same point. That's what makes it continuous. Okay? Endpoints can also be continuous, but they are only continuous if you actually approach that point from the side your function is on. Okay? If you don't approach it, do you know, like we did before when we said 2 wasn't part of it because it didn't. You'll get it. Okay, so write this down. I'll just be waiting. Maybe I'll take a drink of water. Oh, so much better. Do you know that most headaches are caused by dehydration? Did you know that? Super click. Okay. Types of continuity. This is continuous. Okay. Nice handwriting. This one and this one have what are called, you're just missing a point, right? And if you put that point back in, it would work. So it's called removable. Okay. Removable discontinuity. This guy is called a jump discontinuity, because if you're Mario, you'd have to jump up to get on it. The next one, alright, I'm shifting. Too many videos in a row. The next one, it goes off to infinity. They both go off into infinity, right? So you don't ever actually see the point at which they end. That's called infinite discontinuity. Okay? And this one, see how they're oscillating? That's called an oscillating. So 2L. Oh, you guys are going to kill me for this one for not getting it. Oscillating discontinuity. Okay? Okay. Sample continuity at point. If I were to graph this, because I rely on my graphing calculator, you get something that looks like this. Okay, and you see there's a discontinuity here, and it's when my bottom equals 0. and that happens at x equals 1. So if you get one with that's a fraction, that's a rational function, you take your bottom and set equal to 0, and those are your vertical asymptotes, and vertical asymptotes are discontinuities. Because they're infinite discontinuities, right? Because they both go up to infinity, and they are discontinuous. Now, that function has a discontinuity in it, but it's not a discontinuous function because 1 is not in its domain. A function is continuous on an interval if, and only if, is continuous on every point on the interval. A continuous function is continuous on every point in its domain. It doesn't have to be continuous everywhere. Okay? So that function we looked at before, sure, there's a discontinuity, but x equals 1 isn't part of your domain, so it is still a continuous function. Okay? For example, 2 over x plus 2 squared has a discontinuity in it, right here, but it is a continuous function because that's not part of its domain. These rules are silly. What they say is if you have 2 continuous functions, you can add those together and get the same function. It's really, really silly to me that this is a rule. I'm going to show it to you. You don't have to write it. Page down. Composite of continuous functions. What that says is if you have 2 functions, you can take, and they're both continuous, the composite of them is continuous. For example, if I had something like square root of x squared plus 3x all over 2, and I were asked if this was continuous, you don't have to graph it because square root of x is continuous and x squared plus 3x over 2 is continuous, and actually this is a composition of these 2 functions, right? This is an f of g of x. Okay, if you guys need a quick reminder of what that is, just ask in class. I can go over it again. But if you can make up a function from 2 other functions, which are both continuous, then that composite's continuous. Isn't Calc fun? Last slide. Intermediate value theorem for continuous functions. What that says is really important. What this says is if you have a continuous function on a closed interval, like from a to b, and you have your f of a, f of b, like if this was the point 3, 4, and 9, 10, then there is some number you can plug in to get any value between. So if this was 9, 10, this was 3, 4, then if I said, well, does anything in there equal 6? Yes, it has to because it's continuous. You have to hit that 6 to get from 4 to 10. It could go down and then back up, but you have to hit it. Okay, and you may be thinking that doesn't seem very important, but it is going to be very important. So make sure to take notes on this. I hope you guys enjoyed. See you on the flip side.